So problem 9 says that it's an added challenge. You have to write a bash conditional in your script that runs the code only if your job is sent to a particular node. I just gave an instance of N121, it could be anything. Okay, so your script should check for which node your job has gone to, and if the job has gone to N121, only then it will run something, otherwise it will give you an error, or it will type something on the screen that it has reached some other node. Now, another effective way to do that is to actually specify in nodes equal to in the resource list, so PBS hash PBS minus L, and you specify which node you want to send the code to. That way you don't have to write the script. But sometimes we do want the script, the code to run, and depending on where it goes, we want to take an action. So this script will help you. You can modify the script to ensure that the code will go wherever it wants, and depending on where it has gone, you will run the code accordingly. So this checks for using an if conditional in bash script. And the second thing this exercise checks is you being able to extract the host name of the machine, the compute node where the job has gone to. Okay. So I have already written the script earlier, so I will show the script to you on the HPC cluster. Right, so here is a script. So there is nothing special, it's exactly the same as what we had, except that here we have an if condition. So it says if, and then we have to give a condition here. So the condition is to check if the host name, which is an environment variable which exists on the compute node. So this will be the address of the node where the code has gone, the compute node. If that is equal to target node is a variable we have set here. So the question said N121, I have used N31. Okay, so you can read N31 as N121. So this target underscore node is an environment variable that we have set in this script, and you can change it depending on what you want. So we have put N31. So it says that if the host name will be returned by the compute node, whatever the host compute node is, and if that becomes equal to N31 in this case, then the first thing it does is it echoes a message on the screen, which will actually go to out.o, that code running has reached the target node. And then it will do the two things. One is sourcing the virtual environment, then running Python file. Else is if the host name is not equal to target node, then it echoes or prints not running as reached, then it prints the actual node address. So it has reached, actually I could have used host name here. It prints PBS underscore node file. So it has reached this node instead of target node. So target node is N31. So if it reaches somewhere else, it will actually tell you that, just to check it reached somewhere else, not the target node that you intended. So this script I will share with you, but you should be able to understand the logic behind what we are doing here. Okay, and as I said, let's come out of it. Let's run it. So it says R means running, C means completed, so the code has completed execution. So out.o is generated on the 21st of Feb, that's today, so that looks right. Let's look. So it says, you can see it's N31, so it has actually reached N31. It says code running as reached the target node. Okay, so this is testing for reaching the correct node. Let's try to send it somewhere else, and that, or let's change N31 to something else, and then see if it reaches the else condition as well. In this priv seq that I am using, it tends to send things to N31. So I'll change that N31 to something else in the target node. So I've changed it to N33. Again, let's check the status with qstat. It's completed again. Let's do an ls minus l. So you can see, let's check the contents of out.o. Okay, you see that it went to N31 again as expected, and it says not running as reached N31 instead of N33. So target was N33 and N33, and it reached N31, which was the host name. So it did not run. If I send this job interactively, if you remember, with the -i flag, it basically only takes the directives. It does not take the actual content of the script. So it has taken me to N31, and I can use priv env, print env, sorry. It shows me all the environment variables available, and we can see that there is something called host name, which is equal to actually the address of the compute node where it has gone. So this was the motivation to look for where the code has gone to. Is this clear? Yes.
Why use two different files, .pbs and .sh?
That's just, I mean, you can have anything you want. Okay. sh is typically for bash script, and typically for PBS scripts people use .pbs. Just a way, extensions are just a way for people to understand what the file contains. You can have sh also. Questions? Okay, so this was problem 9 in exercise 1. So let's move on to exercise 2 now, which is many people wanted to have a look at this. So this has two parts, the first one and the second and third, which is basically just one problem. So first one is not that interesting, I'll just leave it. Second and third are the more interesting ones. The second one says once the job starts running, you should get an email. Now that's interesting because if you have sent many jobs, let's say, and you are waiting for it to run, and if you are expecting it to run quickly so that you can get a solution and put it in your thesis, then you are too eager, and sometimes you just waste your time trying to check the status again and again. And this third part is to, once the job is completed, even then you want to get an email, and since once the job is completed, then you also have a content. So with that email, you should get the job ID as subject, so that if you have many IDs running, or many maybe job, not job ID, job name, whatever you want, the subject should be concise with the details of the job, and the content of out.o should be actually included in the email message. Let's have a look at the workflow for this. So let's work on once the job gets submitted, it should send you an email. So the first thing typically for any computing exercise like this is to come up with an approach. So what is your approach? You may have multiple approaches. So one is, so I'm going to give you one approach that I tend to use, is that when the code starts running inside the PBS script, I will, in the beginning of the script, because when the code starts running, the script will get sent, right? So it will execute commands. The first command I have is, it generates a file with a certain name. And once that file is generated, that means the code has started. So that's one way to check. If the file exists in the folder, then the code has started. Okay? And you can give it a name which you know. So I typically give it a name which is the job ID and the extension is dot started. So if you find any file with dot started as an extension, that means the job has started. Similarly, when it completes, you generate the last command in the whole script is to generate a file called job id dot completed. You can get job id from those list of environment variables. Okay, so that is easy. So that's one approach, and then you can write a script that checks for the existence of started and completed files, and if they exist, as soon as you figure out that yes, that file exists, it generates an email, and next time it will stop checking because it has already sent one email, so it makes a flag equal to true, so that you don't get emails again and again that the job has started. Now the other approach is that you can actually use the qstat command. If you use the qstat command, you can figure out the job has what is the status of the job. So you can run the qstat command, then whatever the result is, you have to use some sort of regular expression to check if the status of the job is Q, C or R. That's a very good way to check actually, because qstat will have the complete detail of your job in terms of the status. But for that you have to do some sort of text mining as to figure out whether there is the status of the job is Q, R, C, whatever the status is. Okay. So I don't use that approach, but that is another approach that you can use depending on the situations. So let's say we choose the first approach that I mentioned, that there's a started and there's a completed file. Now this approach works in any kind of cluster. Okay, where qstat command may not even exist, some other command is there, so you can use the same script wherever, whichever kind of scheduler you are using. So let's with the first approach, now the next thing is you have to break it down into steps. So I'll discuss the steps with you verbally and then I'll type them out. So the first step is to write a PBS script. So there's two levels of scripts here. One that is running on the cluster, that's a PBS script, and one that runs on your local machine to generate email. Email generation cannot happen on the cluster. Cluster does not have access to generating emails, but your local machine can do anything. You have internet on your machine, you can write any script that you want to generate an email to. So cluster will run the PBS script. That PBS script will have two steps, two modifications in it. One, it will generate a started file when the code starts, and one, it will generate a completed file when the code is about to complete. That's pretty much it, nothing much. So let's have a look at that file first. Right, so this is the script that I'm generating. So it has everything is well known except for this line. Well, this one simply what it does is so it generates a file called PBS underscore job ID. So this is an environment variable which is going to be the job ID, because if you have multiple jobs you will want to separate them based on some ID. So this $PBS job ID will actually translate to the job ID and then dot started. So that is going to be the file name, job ID dot started. So what I do is the first line in this file, the file has to have some text in it, so I can store the node that the job went to. So let's say the job went to N31. So that n31.cluster.itmonday.ac.in will go into this started file. Next, what I also do is as a second line in the same file, job id.started, I include the date and time as a timestamp. So that way is I'll have a record of when the job had started, just to be sure. So when you get an email, you can actually also check if the date agrees with the time of the email. Maybe the local machine, on your local machine the code is running with some delay. So it extracts the date and time on the cluster. So maybe the cluster clock is shifted. In that case, you will get the incorrect values. And then it runs the program. And then at the last, it generates a file called pbs underscore job id.completed. And that will have again the date and time. So date command simply prints the date and time in Linux. Okay. So the modification is in these three lines, 1, 2 and 3. So the idea is to generate started and completed files from this script. So once that is done, then is where the interesting part comes. Next, what we do is we write a script locally, a Python script that runs infinitely. It will keep running, and every time it runs, it will check whether the file started has been generated on the cluster. I'll tell you how, but this is the whole approach. So once the it has found a started file on the cluster, it sends an email to you. It calls a function called send email, and it sends you an email, and it adds some information in it. And then what it does is it makes a flag called started equal to true, because now the job has started. It won't start again and again. That starts so that it does not keep checking for starting. So once the started has become true, now it will check for completed. It will keep running infinitely, and once the completed file now gets generated, it will send you an email. And then once the completed is also true, the flag of completed is true, then the job is done, right? So that you don't need to keep running the loop, because you have sent an email for started, send an email for completed, so it can, program will complete and stop. Okay. So the idea, the algorithm is to run a loop infinitely and first check for started, then check for completed. If it has not started, there is no point checking for completed. It cannot complete before starting. So this is the algo. Let's look at the code. Again, I have written this code, so I'll just show it to you. Right, the code has many lines, but you don't need to worry about. Just focus on the lines I'm talking about. So there is one loop that runs infinitely, and this is called this loop while true. It's a while loop, and the condition it's taking is true. So basically, it will keep running. It will never stop. So while the condition is true, which is true by definition, then it will keep running. So what does it do in this loop? This is the main part. Everything else is just calls to functions. The first thing it checks is if the started flag is false. That means the code has not started yet. If this condition becomes true, that is the started flag is false, then it will make a call to copy the started file from the cluster to your local machine. Because if the code has not started as per your information, then first you have to copy that file from the cluster. That's how you check the existence of a file. So first it sends a copy command, scp command, to copy the contents from the cluster to copy that started file to. Now if the file existed on the cluster, that means it has got it will copy successfully. So then it checks for the existence of that file locally. So let's say the file could be copied if it existed. Then this if condition, which says if the started file name, whatever it is, it exists locally, then it sends an email. Okay, and the email, there's a function called send email, which can take two things. One is called started, one is called completed, and then in the function we'll do other things. So it sends an email of started. Now once it has sent an email, it does not want to keep checking for started again. So then it makes the started flag equal to true. So the next time it comes back to this infinite loop, it should not check for started. On the other hand, let's say the file did not exist on the cluster, it's not even started. So then this condition of existence of the started file name locally will be false. So then it will not go into inside this if loop, and then it won't even go to else if, because this condition was true, started flag. So then it will come out. It comes to time.sleep. So this is basically a command in Python to wait for 5 seconds. So it will wait for, you don't want this loop to run every no, microsecond. It's too taxing on the local machine processing. So think about it. I mean, I'll check after every even 5 seconds is small. Typically I would check after every 1 minute, and then otherwise it will keep sending these copy commands from the to the cluster every 5 seconds, which can slow the things down. Okay, but just to show that I have given 5 seconds. Okay, so let's say started is true now. So we made the started flag equal to true by sending email. Now it goes to this while true again. If started flag equal to false, that is not true. Started flag is true now, so it does not go into the if condition, the first if condition. Now it checks else. If is basically else if. Else, if the first if was not true, then it checks another condition. If completed flag is false. Now that is true. It has started the code, but completed flag is still false. Okay, by default all are false to start with in the code. So now the completed flag is false. Now it sends a call to the cluster to securely copy the completed file. So let's say the complete file has been generated now. After many attempts, it could find the file now. Then it checks for the existence of the completed file. If the file exists, it sends an email for completed and makes the completed flag equal to true. Alright. Now it goes to this while condition again. Started flag is true. It does not go to the if condition. Completed flag is also true now. It is not going to the else if condition. Now it goes to the final else, which says break. So break means it will just come out of the while loop. That's the end of the code. The code stops execution. Your job is done. Any questions about this? I'll share the code with you. You can have a look at it. But for the present discussion, any questions?
Sir, like every script start with that exclamation has been bash bin mark. What does that mean?
Not this one. This is a Python script. That's for bash script. Okay, the bash scripts will start with that, just to tell which shell it's in because you can also run the the bash script by using a /. So when you use a / after the file name, it just figures out what kind of a script it is. It's a bash script. The other shells also available like ZSH, KSH, and so on. So they can also be used. This is a Python script. So Python that way is quite versatile. You can use it for many different things. So let's look at let's look at this send email, because we are sending email now. So this script is I use this script for many different things. Like I sent you HPC logins, I modified the same send email function to do that. So this function is actually quite straightforward. It takes a type. That type can have two types: started, completed. So if it checks if type is in one of these types allowed, which is either started or complete. If not, if you have send email and you just provide done instead of completed, it will crash. This assert will not work. So it will say that type not allowed in send email, and it will crash the code. So this is just to have control over. You can send two types of emails: started or completed. Then these are just things that you want in the email. This email should be sent from my ID. There's an SMTP server, which is the since our institute uses Gmail, so it's a Gmail SMTP server. There's a port. These are standard things available on Gmail website. Then you have to have SMTP lib.smtp command, which basically returns an object of the type SMTP lib to a server object. Again, you can just copy and paste this code, and then you have to have the start TLS. So it's a more secure way of interacting with the server. And now you also want a password. So I typically do not enter my password in the script. So if I share the script with someone, they can also have a look at my password. So I keep a password in a file called password.txt. Again, it's not a very secure way to do things, but sometimes it's just on my local machine, so it's okay. So it opens this password.txt file, and it saves that password into a variable called password, so that I can log into the server now by using my email, which was this, and password. So if you take this script, you simply have to replace this with your email ID at students.itmandi, and you have to, in the password.txt file, you have to keep your password. So this means you have logged in. If you don't get an error till now, things are working fine. Now you have to check whether your email is about starting or completing. So if it is starting, then the first thing we do is we just print the job ID started on HPC in the Python script only, just for checking things. Now it opens the started file name, because remember the started file name had two things. One was the host name, the other was the time and date. So it takes that into the contents of the email. So the email I get will have some content in it, which is going to be the contents of started file name file. Then it generates an email through the message object from to. I am also sending it to myself. You can, if you want to send it to your supervisor, you can have their email ID here. The subject is going to be job ID followed by a space started. So this means job ID whatever ABC has started, and it sends the message. Okay, message sent from me to me with the subject as job ID started and the content as the content of the started file name, which was the host name and the time and date at which the job had started on the cluster. And then it sends the message and it quits. Similarly, if the type was completed, it does the same thing for completed and then it quits. So this function simply has two jobs. One is to start, send an email for starting. One is job to send an email for completing. The rest of the thing is stuff because you have to copy the file from the cluster. So you need a path. Where is the file going to exist? So in my case, it was in demo me522/python. In your case, the path could be different. The job ID again, it depends on when I run the job, the ID gets generated. So the job ID will be according to that. So you have to pass two things to the script. One is the HPC path where the files are going to exist, started and completed. The other is the job ID, because it has to print that job ID on the subject. I also have some variables. So basically, the started file name is of the type job ID dot n199.cluster.idmani.in dot started. So that's the complete name of the job, name of the file. Similarly, there's a completed file name, and then we also have a command to copy, right? So that command which was sent to this sub dot call sub available that allows you to run terminal commands. So the command by itself is basically some text. Okay, so that text that I am running is here. So the text is scp securely copy from my username at CPU HPC colon and then the complete HPC path, which was this path /home/bgaurav/demo/python / the name of the file space where do you want to copy dot / that means you want to copy in the folder where you are running the Python script from. Now that's quite a mouthful, but I'll share the script, you can have a look at it. Let's run it, we don't have much time now. So let's run this script and then see if it works. Well, actually I modified the script to take inputs from the arguments. Let's comment this out for now. The job ID will have to be checked. So let's say I already have, or I don't have that. So let's clean it first. So this the script is called script more practice. So let's run that. ID is 483479. Okay. So let's close it. Okay, so first it copied the file, then it says started on HPC. I've got an email I can see on my phone, and then because the job had started and complete very quickly, so both files existed. You can check that here. Both these files exist now because the job could start and complete in no time, and the script has completed running. Just to show you things, what I'll do is I will rename the completed file to just completed one, and then run the script again. The started email is from me. It has the cluster name and the date and time when things started on the cluster. So the cluster is slightly offset. It says 1837. Send the it ran the started one recently, but the completed is not running. That's because I renamed the file. So that's locally the file existed. It's checking for the local presence, right? So I have to remove the completed. It tried to copy, it could not find, but it still found it on the local machine because I had just run the code again. So if I run it again, you get the idea now. Okay. One thing I want to you don't necessarily need to pass these things in the code, otherwise you have to modify the code. So you can pass them as system arguments. So this sys.argv this is a list that contains the arguments you pass to the code. So if I run this code now, let me just copy this path. So the first thing I pass here is this, and the next thing I pass is the job ID, which is 480647. Let's say. So sys.argv of 0 is the code name, argv of 1 is whatever you pass after that, and argv of 2 is whatever you pass after that. So the sys.argv basically contains a list of things you pass when you run the code. Okay, and now it's trying to run with this job ID. I think it cannot find that on the cluster, so it's just waiting. 479 exists, and I passed 647. Okay, so if I passed 479 and press enter, then hopefully it should be able to. Sorry, 483. Okay, so this allows you to write the code so that you don't have to